So we've done the side, side, side. We've confirmed that. We've confirmed side, angle, side. We've confirmed angle, side, angle. There is no angle, angle, angle postulate because the triangles could be different sizes. There's no angle, side, side, or side, side, angle postulate, and we won't go into explaining why. Good rule of thumb is ASS spells a bad word, so it doesn't work. All right? So ASS, angle, side, side, doesn't work. But there is a special case of angle, side, side. When you have a right triangle, that means a 90-degree angle. When the angle is 90 degrees and the hypotenuse and one of the legs matches, then the triangles will be congruent. So we're going to explore that. That's called hypotenuse leg, or the HL postulate. So to begin with, we've got to have a right triangle. Okay, so we can't just draw any generic triangle. We need a right angle. So I'm going to draw a line segment. Okay, AB. Okay, and you don't have to make it perfectly horizontal. It's actually more interesting if you don't. Okay, there is a tool called a perpendicular line tool under the construct tools, and we're going to use that. We're going to click perpendicular line. I'm going to click on point A, and I'm going to click on line segment AB, and it draws a line for me. Now, the cool thing about this is if I change any of the drawing, it always remains perpendicular. That's going to be a 90-degree angle. That's locked. Okay? So we have a 90-degree angle. Okay? And now I'm going to put a point on that line segment, or that line, that perpendicular line, and I'm going to draw a segment CB. I'm going to draw a segment CA as well, and I'm going to use the move tool to change the colors to blue. Okay, we've been using blue for our original triangle here. There, I think I used the wrong blue here. All right, there we go. So we've got a right triangle. And it has to be a right triangle. We can change B, right? And C changes apparently as well. Okay, but we can change C. We can change it to just about any right triangle you want. Okay, so I need to construct another triangle that has a right angle and whose leg and hypotenuse match. Okay, so we're going to start with another right angle. Okay, let's do this. Let's do it this way. I'm going to use my compass tool, which we've used before. I'm not going to use the pen here, and actually have better luck with this with. There we go. Now I can use my scroll. Okay, so I'm going to do the compass tool. I'm going to measure AB with my compass. Right, so I've got a circle of radius AB. I'm going to put it over here, and I'm going to put a point somewhere on the circle. Okay, and I'm going to draw a segment. So DE is tied to the length of AB. So as B moves, as B changes, so does DE. Okay, all right. And now I want to make sure I've got a right angle. So we're going to use our perpendicular line tool. Okay, and I'm going to click on point E and line DE. I could have clicked on point D as well, but the point is I now have a right angle. DE is the same as AB, and angle E is a right angle. Okay. Now, the only other requirement of hypotenuse leg, I've got a right angle and I've got a leg that's congruent. I need the hypotenuse. I particularly need CB to be congruent. Okay, so I'm going to use my compass tool, okay, to measure C to B. Okay, there's CB measured, and I'm going to put that centered at D. Okay. And you'll notice that circle intersects the perpendicular line. So I'm going to put a point at the intersection. I'm going to draw a segment DF, and segment FE again. so that I can choose the Move tool and change the colors to red for our final triangle here, so we can verify. Now, on initial inspection, it looks like these triangles are congruent. Okay, and as I move C around, F moves around, right? As I move B around, it moves. It doesn't change orientation with it, but they seem to be congruent here. I can change the orientation by grabbing this and moving it around. Okay, but let's verify. We're gonna verify here, and we verify by measuring. Okay, one more change before I go. I'm gonna just turn all of these into dotted construction marks so we can emphasize what I want to emphasize. Or emphasize. Okay, here we go. Dotted here. Good. So that the triangles stand out more. All right. And let's do some measuring. I want to measure segments, so distance. Okay. And AB and DE are both 7.8. No surprise there, because I constructed it that way. BC is 9.1 and DE is 9.1. No surprise, because I used my compass and measured that. Now let's check AC and DEF. We did not measure those. That's 4.7 and 4.7. So surprise of surprises, it's the same length. Okay. And let's go ahead and measure angles. So I'm going to use my angle tool. Measure angle A. No surprise here, that's going to be 90 degrees. Measure angle B. That's 31.2 degrees. Measure angle C. That's 58.8 degrees. Measure angle E. That's 90 degrees, no surprise. Measure angle D. Hard to read, I'll pull that out here in a moment. Measure angle F. Okay. And grab my move tool. The thing I keep doing is forgetting to grab the move tool to when I want to select something here. So let's move things around a little bit so they're more legible, not covered up. Grab our measurements and move them out where they can be read. Okay, so our angles are 58.8 and 31.2, 58.8 and 31.2, so we've confirmed it. These triangles are congruent by the definition of congruent triangles, which is that all three sides are congruent and all three angles are congruent. Hypotenuse leg is confirmed.